Welcome to day 13. We're going to talk about section 6.11, the change of base formula. So this is just another way that we can evaluate or simplify logs where we can't necessarily get common bases if we convert. So what is the change of base formula? The change of base formula says if I have log base b of x, I could rewrite it as log base a of x over log base a of b. Another way we could think about this is I could rewrite this as log of x over log of b. The log of the argument over the log of the base. So we can convert that to a base 10 or a common log. And that's the easiest base to use, and that's the most common way we're going to see it. Okay, so remember log of the argument over log of the base, and we just turn it into base 10, and now we can use our calculator to plug in those two logs and evaluate. Okay, so let's go to our first example here, where we have to evaluate and simplify log base 4 of 563. Now before, our first step would be to set it equal to x, right? And we would convert, and we would get 4 to the x equals 563. And we would try to get common bases. Well, between 4 and 563, there's no way we're going to get common bases. So what would we do? Well, we would take the log of both sides, and at the same time, I'm going to move that x out front. So we would have the x times the log of 4 equals the log of 563. And then we would divide by divide by log of 4. And we would get log of 563 divided by log of 4, right? Well, that essentially brings us to our change of base formula. So if you recognize that we can't get common bases here, if we were to convert it, so you might be able to visualize that in your head, you can simply just jump straight to the change of base formula. And now when we plug that in to our calculator, you should see a log key, a common log right next to your number 7. So we would plug that into our calculator, and rounding to 3 decimals, we would get about 4.568 as our final answer here. Okay, so we've been using change of base formula, right? It's just a shortcut. So again, if I know I can't get common bases, I'm just going to rewrite it in my change of base formula. Log of my argument over log of my base. Throw it into the calculator, and we got ourselves the answer. Okay, so let's look at this next example over here. Log base 8 of 0.0039. If you were to visualize converting this to exponential form, would you be able to get common bases? Probably not. Go ahead, set up your change of base formula and throw it onto your calculator, see what you get, and check back when you're done. Okay, so I converted it to I used my change of base formula, log of my argument over log of my base. Threw that onto the calculator, and I got negative 2.667. Okay, now again, could you go through it and take the log of both sides after you convert it? Absolutely, but if you recognize that you can't get common bases, this is a much quicker way to evaluate. You must show the change of base formula if you are using it. Otherwise, you will not get credit on the quiz. Okay, with that said, go ahead and try example 3, or this third example right now. Go ahead, work it through, and then see what you get. Check back when you're done. Okay, if you use the change of base formula, you get log of 13.7 over log of negative 2, and your calculator is screaming an error at you. Why? Well, I could have looked at this log right from the get-go, and I could have told you that we were going to get an error. All right, and I could have told you that there's no solution, no real number here. Why? Well, remember the definition of a log. Our base must be greater than 0 and it can't equal 1. Well, in this case, our base equals -2, which doesn't meet the criteria here. So therefore, we could strictly jump straight to our answer of no real number. Okay? So if you recognize that, don't forget about the rules of logs and the definition of a log. The base has to be positive and it can't equal 1. And think about the argument as well. Your argument has to be positive. All right, so if you recognize that, jump straight to your final answer of no real number. Okay, this last section is we're going to quickly evaluate and simplify these logs. Now again, we can think about the steps and the process. We could say, oh, set it equal to x and let's convert. Well, if we do that, we get 49 to the x equals 49 to the 8th. Well, our bases are already the same, 49 and 49, so we would zoom in on those exponents, the powers, and we would say, oh, well, that means x has to equal 8. Okay, well, here's a shortcut. I don't necessarily need to go through this whole process. I could recognize that when the base of my log is the same as the base of my argument, we are simply left with the power. So I could jump straight to saying our answer is going to be 8. Okay? When the base of your log is the same as the base of your argument, you are left with your power of your argument. Okay? All right, so let's take a look at this next example here. And let's first focus on this piece of it. This log base 24 of 24 to the -2/3. Well, we should notice the base of our log is the same as the base of our argument, so what are we left with? We are left with the power. So what we really have is I'm going to carry that 3 on down, and we are left with -2/3 as the log base 24 of 24 to the -2/3 simplifies to. And now we can just multiply that out to get our final answer. The 3's will cancel, and we'll be left with -2 as our final answer. All right? Now, let's take a look at this last example here. This is a little different because this is an exponent. So we have 3 to the log base 3 of 7. Well, it's kind of similar, but what we should notice is when the base of our exponent is now the same as the base of the log with which we are raising it to, we're going to be left with the argument. Okay, so we could go ahead and say, oh, the base of my exponent is the same as the base of the power of the log within my exponent. I'm left with my argument as 7 for my final answer. Okay, if you have questions, let us know.